started. So, for those of you who don't know me, my name is Dan. I am not the Professor Dan. There are many Dans, but I will be the TA, and today I'm going to go over a Python introduction. So there's a lot of people coming from a large variety of backgrounds in this class, and not all of them have the same amount of programming experience, and some may not have any programming experience. So what I'm going to do today is just go over the basics of Python. We're going to just show you how to use Jupyter Notebooks, which is the development environment that we're recommending for the class. And so if these two things are very familiar to you, you might be bored, and I won't be offended if you leave. Okay. One sort of administrative announcement is that we're going to be releasing a quiz tomorrow, and I think Professor Roth talked about the quiz structure, but the quizzes are going to be on Canvas. I think it'll take maybe 10 minutes of your time to do. The idea is that we're going to release these quizzes every Thursday, and then they'll be due Sunday night. I know that there's a lot of waitlist issues. I don't have any information about that. But if you are waitlisted, that means you don't have access to Canvas, which means you can't actually complete the quiz. And so I think we're going to try and, for just the first quiz, we're going to release it as a PDF to everybody on the website. And if you're on the waitlist, then you'll still submit it to me, just like you did for the homework 0. Good? Does anybody have any administrative questions before we start? Yeah.
Do you know when we get back our grades?
No. I mean, so we're waiting on, so the homework 0 is just pass-fail. So we're not really going to grade each individual problem, just sort of for completion. We're waiting a little while to release the solution because there's still some people, I'm still getting homework 0s for some people. We're not taking off credit if you submit it to me now because we understand there are lots of waitlist issues, but after that gets done, then we'll release the solution. Anything else? Yeah.
Some links in the website say that I'm not authorized to.
Are you trying to click on things in the future?
Like the Python.
Yeah, so I think the stuff up to the current day should be available, so like the Python stuff will be after this lecture. I'll try and put it up. Yeah. Yeah. If you send it to me? Probably not, but I probably received it. I wouldn't stress too much about homework 0. If you think that you submitted it to me, but then you never end up getting a grade, then we can work it out and figure something out. Yeah.
There's a Python session this afternoon.
Yes.
That's different from this.
So the recitation section will cover a lot of the same material. It's still going to be a review of Python. It's going to be a little bit smaller group, so if you have specific questions, then you can ask the TAs who are leading those recitations. And if some people haven't been able to successfully get Python installed on their machines at that point, those TAs during the recitation will be able to give you more one-on-one assistance with getting Python installed. I think that they are on the website. If they aren't, then I can, so the recitations are right here on the website. So these are the two that we're offering. Okay, cool. So did anybody try and install Python on their machine last night who didn't already have it installed before? Yeah, and was it successful or no? Yeah, successful, okay, that's good. So I'm very, very briefly going to go through that. So on Piazza, I posted this sort of HTML file where you can look and get links to download Python. So the way that we recommend installing and managing your Python installation is through Anaconda. So if you click on Anaconda, this will be different for your specific operating system that you have. But so I can only really show you Mac easily, but you go ahead and you click on the Python 3.6 version. So there are two popular versions of Python. One is Python 2, one is Python 3. For this class, we're going to be using Python 3, and so that's the one we would like you to click download. So I pre-downloaded this package. On Mac, it'll come up with this little PKG file, and then you go through the steps to install it on your local machine. I also last night sent out on the Piazza post, there was a link to last year's slides on Python, and there were picture installation instructions for the Windows. So if anybody is using Windows, then you can find more detailed instructions there. But once you have installed it on your machine, the Anaconda installation should already have Jupyter Notebooks installed. But if not, then you can go to jupyter.org/install, which is also here, and this will walk you through how to install Jupyter with pip. Does anybody not have experience with working with the command line? Okay if you haven't. Okay. So I bet somebody has, but just didn't raise their hand. So if you are on a Mac, and so after you've installed Python on a Mac, if you press the command key and then space and then type terminal, and then you hit enter, it will open up this terminal. And if you had Python successfully installed, you should be able to type Python, hit enter, and then this screen should appear. And if this does appear, then that means Python has been successfully installed on your system. To get out of this, you just type exit with parentheses and hit enter. Okay, so that's good if you have Python installed, and then to ensure that you have Jupyter Notebooks installed, what you'll do on the same command line is type Jupyter and then Notebook, and you hit enter. And what that should do is that should open up something which looks like this in your default browser. Any questions so far? Yeah? Okay. So what I'm going to do, what is a Jupyter Notebook? So a Jupyter Notebook is sort of a tool which aids you in writing Python code in a way that we think is sort of developer friendly and good for smaller projects that sort of fit in one large file. And the way that it works is that the file that I sent out before was actually developed in a Jupyter Notebook, but there are these different cells. So all of these are cells, they're text cells, and there are program cells. And so you can write your Python code into these program cells, you execute them, and then after that's done, those variables are all saved in memory, and you can use them later on. And so the way that we see most people developing this is that you'll write a little bit of code in a cell, you'll execute it, and then you can, in the cell below that, write a little bit of print statements to test and make sure that it's the output that you expected. And then if it's not, you can go back up, edit the code, rerun it, and kind of go back and forth in testing your Python code this way. So that's basically what the main feature of a Python, or the Jupyter Notebook. Okay, so if you don't have Python experience, I pointed you to this this website on Google that they use to onboard people to Python internally. And just be wary that they use Python 2 by default, and there are some breaking changes between Python 2 and Python 3. If you care about these things, the major ones are listed there below. Okay, so who has a lot of Python programming experience? Like they're very comfortable with Python? Okay. Okay, that's actually less than I imagined. Okay, if you do have programming experience, but it wasn't in Python, was it in Java? Okay, lots of Java. MATLAB? Okay, anything else? Yeah. What was it? C, okay, yeah. Same thing? Okay. Okay. So, in this section, I'm just trying to talk about kind of what is Python, and compare it to something which you may know before, because there are always differences between programming languages, and we're just trying to get everybody up to speed. So unlike C++ and Java, Python is what we call interpreted, which means that you never actually hit a compile button. So you just write the code, and then you run that file, which the code is in directly. Whereas in Java, you type javac, or you'd use Eclipse or something to compile it and run it first, and similar with C++. So the main difference between, or one large difference, which might be surprising if you only have Java or C++ experience, is that Python is what we call, it's not statically typed, which means that you can declare a variable and set it equal to an integer, and then in the next line you can use that same variable and set it equal to a string, and there's no problem. So in Python, there's actually no type declarations. When you, the new keyword for instantiating an object is not used like it is in Java. Another surprising difference is that Python doesn't use curly braces in programming at all, like Java or C++ does. It actually just uses white space to imply what the indentation is. And so I'll go over the details of for loops before, but in a normal Java environment, just that one line underneath the for loop would be considered within the scope of the for loop, but it's actually both of those two lines underneath the for loop in Python because of the functions can't be overloaded, instead use optional arguments. That seems kind of advanced, so I'm not getting into that. One annoying thing is that, that true and false are now capitalized, they're not lowercase. Who knows why? So for the people who are coming from MATLAB, the main differences that you'll see is that Python uses the hard brackets to index arrays and lists and strings, whereas MATLAB uses parentheses. And in the MATLAB world, things are one index, which means that the first item in a vector or a list is at index 1. But in kind of the rest of the programming world, it's actually at index 0. So Python is 0 indexed. Okay, we'll get to NumPy later. Okay, so there are a variety of tools that you can use to help write your Python code. We are, like I mentioned, we are going to be using Jupyter Notebook. This is the framework that I'm using right here. There are other things. You could just use a plain text editor. You can use Python, or you can use this Google Collaboratory. Google Collaboratory is very similar to Jupyter Notebooks, except the code actually runs on Google servers. There's other class who use Collaboratory in previous semesters, and people complain because sometimes the code, the running would time out, or if you close your laptop, it would stop running and that sort of thing. And so we are recommending you just use Jupyter Notebook so the Python code runs on your own machine. But feel free to use those others if you are familiar with them. Yeah.
If you only use Python 2 listed, I think you may have said it already, but like, is there I don't see it as an option when it's the default. If I type Jupyter Notebook in the command line, it's launching. And then in the upper right-hand corner, I only use Python 2. I don't see environments within the Anaconda, so I think that's part of the problem.
Right. You might have to switch the, I thought there might be a way to switch environments here, but I guess there's not. I don't know the answer to that without actually looking at the machine. It might be slightly complicated because you might have to force the Jupyter, you might have to, when you launch Jupyter with Jupyter Notebook, you might actually have to, where's the Jupyter? You might actually have to specify on the command line that you want to use Python 3, but I can figure that out, and maybe I'll put a post on Piazza after. No, but I think it'll be a common confusion that a lot of people will have. Okay. So I've already discussed Jupyter Notebooks a little bit. Here's more text that if you want to look at it later. One thing which is important is that before you close your notebook, that you should, that's kind of annoying, that you should save it so that what you've written and done so far is been saved to your computer. When we submit it, when you all submit your assignments, and we'll talk about this later when it actually comes closer to a homework and submitting assignments, there's a way that if you, so the file that we're actually editing is .ipynb, IPython notebook. That's what Jupyter Notebook used to be called. And in order to convert this to a .py file, which is what you'll need to submit the homework, you can just go to File, Download As, and hit Python, and it will convert all of this into a Python file, which you would then be able to upload to Gradescope when we get there. Okay, any questions so far? Yeah.
The HTML version of this page is working, but I can't find the.
So if you download the IPython notebook file and you launch the Jupyter Notebook through the command line and navigate to that IPNYB file, you should be able to open that. to a PDF, so that's why I had an HTML file. But if you download that IPython notebook file and open it with Jupyter, you should be able to execute the code and edit it just like I am right here. Okay, so now I'm just going to dive into a whole bunch of basics about Python, the different data structures and types that you might want to use, some differences between Java and MATLAB, as well as some pretty useful libraries that are used a lot in Python. So assigning variables, there's really nothing tricky here. The only thing which might be surprising, which I already talked to, is that you don't actually declare any types. So you wouldn't say float x equals 4.2, you just say x equals 4.2, and it's actually an error if you include the type. You can change the type of the variable without a problem, which is what I discussed for the static typing. And one thing which you all will probably get used to a lot is these great print statements. So if you want to actually display the value of a variable, you can just type print, parentheses with that variable, and after you execute the Python cell, so I can just execute this, the value of that variable is actually printed below. So this is where you can see the output of your cell after you ran it. The equivalent of a null type in Java is called none, a capital N, so you can use that as the same way that you would. So if you want to see if z is equal to none, that should say true, and so that's how you can kind of do null checks. Okay, so now we're going to go through some common string operations. So just defining a string, you can optionally use, in Python, single quotes and double quotes mean the same thing. So these are equally valid statements. There's really no difference between them. To get the length of the string, you can use the special len function, which you pass it the string as an argument, and it will return the value for you. Indexing is very standard. Like I mentioned, Python is 0 indexed, so the 0th character will be A. So the last one will be the length, which is 6 minus 1. It'll return F. If you try to index outside of the length of the character, or the length of the string, it will cause a runtime error. One thing which is new for people coming from the Java and C++ background, but is very similar in the MATLAB world, is this range indexing. So S is still our string, but if I want to take the first, second, and third characters from S, I can do that with this colon operator. Like most other programming languages, the lower bound is inclusive, the upper bound is exclusive. And so this will give me the characters, the first, second, and third, first, second, and third characters of the string. If you don't include an argument as the upper bound, it will take from the index you give it all the way to the end. And if you don't include a lower bound, it will give you everything to the end, or everything from the beginning up into the index that you provide it.
Yeah, and isn't it the second, third, and fourth, though, because it starts at index 1? For 1 through 4?
So this will give you, so it starts at 0. So A is 0, and then it will give you, are you talking about for this one?
Well, you said it was the first, second, and third, but is it because it starts at index 1?
Okay, so it'll be the first, second, and third index, the second, third, and fourth, or characters, or whatever. Yeah, sorry, yeah. One thing is weird about the range indexing is that you can give it an index which is significantly larger than the length of the string, and this will be fine. So for whatever reason, this crashes, but this is totally fine and gives you up until the end of the string. Another wacky thing which is in Python is negative indexing, which you all might find to be incredibly useful. So in many other programming languages, if you try to index by a negative number, you're going to run into a lot of issues. But if you index by a negative number in Python, it actually starts to index from the end of the string. So S of -1 is the last string, or the last character within the string, and -2, and so on and so forth. You can do all of these wild things where you select all of from the beginning until the end, except for the last character, which will do that here, and except all the way up to the -3rd character. And this is just some weird syntax for actually reversing a string. I don't expect you all to already have memorized all of this, you obviously have access to it, and this is more for a reference, so that if when you're doing the homework assignment, you can actually look at this and say, oh, how did you do that? One thing, concatenation with another string is pretty straightforward, right? You just add the plus sign. But one thing which Java will do by default, if you try to concatenate a string and an integer in Java, it will implicitly convert the integer into a string and then do the concatenation. However, that doesn't actually work in Python. The program will crash if you do that. And so what you do is that you have to use this string function and pass the integer, and this will be converted to a string, which you can then concatenate with the input string. So this str function is probably the closest equivalent to Java's toString that exists in Python. So whenever you need to convert something to a string, you can use this str method. The other useful function, which I use a lot in my own work, is the split method. So if you recall, this is what our input looked like, and I asked it to split the string on the value capital C. And what it does is that it will take the input string, and whenever a C is present, it will delimit it. And so this actually returns a list of two different strings. One is AB, and the other one is DEF. And we'll talk about lists pretty soon, might be next. So if you have a comma-separated file or a tab-separated file, you can read the whole line into one string and then use .split on a tab or .split on a comma, and then it will divide up that string into a whole bunch of columns for you. So this is a very useful function. Any questions about strings? Okay. Am I good? How's the speed? Fast? Slow? Fast? Slow? Yeah.
Not to go back, but I solved the other problem.
Uh-huh.
You're missing the Python brief and the Python notebook. You just do pip3 install dash Jupyter, and then it adds.
Jupyter?
Pip3 space install space dash capital U.
Oh yeah, yeah.
Space Jupyter, and that will add it.
So I just didn't know then when you launch the Jupyter Notebook, how does it know which Python to use? Because then you have both.
Updated it to P3, so now I don't have two now.
Okay. Okay. So basically, sounds like just do this. Okay, I gotta keep going. So lists. So lists in Python are used constantly all the time everywhere. They're roughly the equivalent of an array list in Java. So you can initialize a list by giving it a series of items like this with the hard brackets. The hard brackets in Python denote lists, or you can just initialize an empty list with empty brackets like this. And many of the string methods also work for lists. So probably in the back end of Python, that strings are probably just implemented as lists of characters, but I don't actually know. But if you want to take the length of a list, you can do it the same way that you did of a string. The indexing is identical. It does all of the same things as you would expect it to. One useful thing is that if you want to sort a list, you can use this sorted keyword and pass it the list which you would like to sort. This returns a copy of the list which you sorted, so it doesn't actually sort it in place. So that might cause some bugs if you're actually expecting A itself to be sorted. And you can pass a reverse argument. You could say reverse equals true to sort the list in reverse. So I forget how you add to the end of an array or a list in Java. It might be like add, actually. But the equivalent of that in Python is append. So you say a.append, and then whatever item you would like to put onto the end of this string. There's also another funky syntax where you can say a plus gets and a string, or a list, and it will append this list to a. So it's actually kind of nice way to do it. So because everything in Python, the types can change and it doesn't really matter, you can actually put any type of object that you want within the same list. And so this is not easily possible in Java, because in Java you'd have to have an array list of type integer, whereas here you just have a list and you can put whatever you want into the list. And so here I had a whole bunch of integers in my list, and then you can just add a string as well. If you want to search to see if a value is in a list, you use this in keyword. And so this checks to see if the number 8 is an A, and it will return a Boolean about whether or not that's true. Okay, questions so far? Still good? Okay. So dictionaries are the other sort of fundamental data structure that is used everywhere in Python. So a dictionary is like the equivalent of a hash map in Java. So it's a mapping from some object to some other object. The way that you initialize an empty dictionary is with these curly braces. So the hard brackets were for lists, the curly braces are for dictionaries. And then to insert an item into the dictionary, you can say the dictionary with hard bracket, whatever item you want to be the key, and then put whatever item you want to be the value there. And so when I print this, it's actually going to print this, this dictionary, which looks like this. You could do the same thing here. This is just emphasizing that the dictionary, like the list, doesn't really care about types. So here, here is a string as a key. Here is an integer as a key. And I'm passing it a list as the value, and here I had an integer as the value. So you can really throw whatever you want into these dictionaries. As I was saying that, I realized I missed the distinction when I was talking about the double quotes versus single quotes. In Java, single quotes denote characters, but and double quotes denote strings. That distinction is lost in Python, so everything is a string. There's this notion of a character doesn't really exist. A character is just a string of length 1, which is why the single quotes and double quotes don't make any difference. Sorry? The key? I'm not quite sure if I understood the question. So what this dictionary does is that it'll map from one object to another object. So have you used a hash map in Java? No? Okay. I wonder if I have a good list. So I'm not quite sure how to explain it, but it creates this data structure so that it takes the string A and it maps it to the value 97. It takes the string C and it maps it to the value of 99. And I don't think I actually do any indexing here. But let's say that you wanted to get the value at A. You can index it like this, and you can say, what is the value in the dictionary given the key A? And this will return the value of 97. Is that enough? Okay. Okay. Yeah, I'm not sure. So it's really just a way to map a key to a value. Okay, sorry. So if D is your dictionary and you want to retrieve all of the keys which are in the dictionary, you can actually say .keys with parentheses, and this will be, I guess, A, C, and 0 so far. And if you wanted to retrieve all of the values, then you can do the same thing for values, and it will return something which looks like a list. You can read this note if you actually care, with all of the values which are in the dictionary. Similar to the list, if you want to see if A is a key in the dictionary, you can use A with the in operator and D, and this will check to see if a value is there or not. And to delete an item from the dictionary, you delete the key, and you use this weird notation with the del operator. Any questions? Cool. Since most people, I don't know if there are that many people without programming experience, I'm going to go through this quickly because I don't want to go over the semantics of if statements. But you can kind of see how this works. So double equals works the same way that it does. At the end of anything where you want to have the equivalent of a curly brace in Java, you actually use the colon operator and then the indentation after that. So this is how you do an if-else statement. Not equals is exactly how you'd expect it to be. Less than or equal is normal. Instead of the double ampersand operator in Python, you actually use the word and. Similarly, you actually use the word or instead of the two pipes. This might scare a lot of people who are coming from a Java background because you were told many, many times never to compare strings with double equals in Java, but you can do that, and that's how you should do that in Python. This is weird, this might trip you up. This is how you write else if, it's just elif, which is sort of annoying, but it is what it is. Okay. So for loops. So in this example, we're just going to use this list right here. This range function is a really nice way to generate a series of numbers. So if you say range of 5, this will dynamically generate for you the numbers 0 through 4. And similarly, if you say 1 through 5, it will generate 1 through 4. And the reason that I brought this up is because for loops in Python use this in operator. And so you'll say, so the length of A, I don't know, what is that, 5? And so you can say for I in the range of the length of A, which is 5. And so this for loop will run once for 0, run once for 1, 2, 3, and 4. And then you can do exactly what you would normally do in other programming languages. So this is sort of the direct translation from how you would do a for loop in Java, and I converted it to Python. The more Pythonic way to do a for loop is that you can just just directly iterate over all of the elements x with an a. So both of these for loops are equivalent, but this one will just print all of the values. So x will be 0, then 8, then 3, then 5. If you need to iterate using a for loop over the items in a dictionary, you can do this .items function, which will return pairs of the key and the value. So this is a weird Python syntax because functions in Python can actually return more than one variable. And so to split the items will return a key and a value in succession. And so you can use this comma operator to assign the key and assign the value to items. This is another useful operator, the enumerate operator. So what the enumerate operator will do is that it will give you the index and the item as it's iterating through, let's say, the array. So this will iterate, item will be 0, 8, 3, 5, 1, but then the index will be equivalently 0, 1, 2, 3, and 4. And so this is sort of combining the best of both worlds from this normal for loop, which uses the index, this for loop, which uses the item. This, you can have both of them. For loop questions? Nope. Okay. Is this boring to most people? Yeah? Okay. No reaction. Great. Thank you. Okay. Some methods. So this is how you define a function in Python. Use this def keyword, which just sort of stands for define, the name of the method, and then the arguments it takes. It looks very weird because there's no return type, because there's no return types in Python. You don't actually have to say that this is an integer. You just say what the value is. And so the return keyword, it works exactly as you would expect. What am I showing here? So I think here I'm going to show, so I'm assuming that the user is going to pass in list 1 and list 2, and then I concatenate list 2 to the end of list 1. And I'm just kind of showing this as an example that if when you pass objects, they're passed by reference, they're not copied. So this will actually edit list 1 in place. Function calls work exactly as you'd expect them to. Python has this weird thing where you can actually pass name variables to functions. So if you see this add method takes x then y, but what you can do is that you can say y equals 8 and x equals 2. And even though these arguments are not in the order that you would expect them to be, it's going to work exactly how you would want it to work. So this is just demonstrating that A1 is actually edited with this concat. And this is an example. of where I'm demonstrating how you can return multiple things with in Python. So when you say return, you can return one item, put a comma, and then return the second item. And in order to split these apart, you say A3, comma, A4 equals 2. So A3 will get A plus 1, and A4 will get A plus 2. So it's actually kind of nice. If you did T equals 2 of 1, so even though 2 is returning 2 values, T is now a tuple of size 2. And so you can print T0, or you can print T1. And so if you don't want to use multiple variables, you can just take the tuple just like that. Okay, so lists and dictionary comprehension. This is also another sort of Python specific thing. So we just have this method which adds 1 to a number. And let's say that we want to apply that function to every value in X and store it in Y. The normal way that you do this, sort of like in a Java style, is you'd have a for loop for all of the items in X. You would add 1, you'd call add 1 on each of the items, and you would append that result to Y. But the more Python way and easier to read, and it's cleaner, and there's only one line of code, is that you can do what's called a list comprehension. So the syntax looks like this. So you say add 1 for x of I, and the for loop is for x of I in X. And so what this does is that this will iterate for every single item in X, and it will call the add 1 function on those items. And so these are exactly equivalent, but like I said, I think that this is a lot easier to read. You can also do more complicated things. So you can say for x in I if x sub I is greater than 1. And then this will still iterate over all of the items. It'll first do this check with the if statement, and then it'll call the function if it passes the check. So you might see this in Python code, and it's useful to know about. So this is another way to create a dictionary. So this is a dictionary comprehension. So if we look at just this part, we're still iterating over, I have, I guess, x of 1 here. So for x1 in X, we're going to do the following. We're going to take x1 as the key, and then this colon operator, and then x1 times 4. And so what this does is that this will create D as a map, or a dictionary, and it will map from all of the items in X to all of the items in X times 4. So again, this is just sort of a cleaner way of very compactly representing all of these for loops. And these are kind of used in Python a lot. Cool. Still no questions? Great.
Is that taking away the first column, x1?
Sorry?
X underscore 1.
Yeah.
Is that on the first column?
No. So I thought that when I had done it, I had, no. I don't know why I chose 1. I didn't mean to. This doesn't actually matter. So this will run, this for loop will run for every single item in X, and I'm just calling each of those items on each iteration xi. Mm-hmm. Yeah. Exactly. So this is this print statement here, or this output is coming from where I'm printing the dictionary. This is just the equivalent of the dictionary's toString method in Python, and so this is the key, colon, this is the value. This is the key and this is the value. And so if you see here, 0, 1, 2, 3 are all keys in this dictionary, and then that value times 4 is the value. Yeah. Mm-hmm. Okay, cool. Files are very important. So here I have 2 quick demos. So in this input file, I have a file in the same directory as the Jupyter Notebook, and it's just called input.txt, and on each of the lines, it has the lowercase versions of all of these letters. So it'll have A, B, C, D, all the way to G, and they're all lowercase on one line at a time. And so in a lot of your homeworks, we might give you a data file, and you'll have to read this data file into memory and do some processing on it. And a common way that I would recommend you do that is with this kind of format. So This looks really weird to a lot of people, but you'll get used to it. So you say with, and then open is the function which opens a file handler. You pass it the name of the file, and then you pass it an R if you want to read that, if you want to read the file. And you say as f, which means f is now the variable which stores the file handler. Now we have a file handler, and so now we can iterate on all of the lines in f. So if you say for line in f, this will be a for loop, and each time it will process one line at a time. Line will have the new line character at the end of it, which could be annoying depending on what you're trying to do. And so this strip function that's just called on strings will remove the white space from the beginning and the end. And so this is a pretty common template which I do in a lot of my code to just get rid of that new line character because I don't want it. So in your homework assignments, you're probably going to have something which looks like this a lot, and then you will probably apply you'll parse it, you'll convert things to integers, and here all I'm doing is that I'm taking this line and I'm converting it to an uppercase version of the string and saving it as upper, and then I'm appending it to this list called lines. And so when I print lines, it's actually just going to have all of the lines from the file, but converted as uppercase. Okay? So then, now I'm going to save this data to a file, and I'll write it to a file one item at a time. So we use the same with open format, the template. You put the output file, and then you put W, which means that you want to write. And when you pass W, it will overwrite whatever file currently exists. So you be careful if you care about what you're about to write. And then the file handler is just what I'm calling out. These are standard names. And then I'm iterating over all of the items in lines, and then you say out.write, and whatever you pass to write has to be a string. And so you have to convert whatever item you're trying to save to a file to a string. By default, write will not add the new line character. So this is sort of like system.out.print in Java without the ln. And so you very often have to add a new line character. So you might be thinking that you actually need to close this file handler, or why don't you have to close the file handler? And that is actually taken care of by this with statement. So as soon as this variable out goes out of scope, and the scope is defined by the with statement, it will close the file for you. And so it's just good practice to use this with statement so you don't accidentally not close a file. Any questions? I know like sometimes reading and writing files is important, and sometimes it's hard to get right depending on the language, especially in Java, because there's like 100 ways to read in a file. But this is a pretty standard way to do it in Python. It will crash. Yeah, so I actually didn't put exception handling in here. I can. I thought that most people were going to have more Python experience than it looks like they do. So I didn't include a lot of more advanced stuff, but I can add that if people are interested in seeing like exception handling and that sort of a thing. Okay. I'll post that on Piazza. If I forget, somebody remind me.
Is there a return value for a function?
So the answer is yes, and the variable which is returned is saved as the variable out. It's just a really weird syntax, but you could see this as saying, okay, so what you could also do is you could say out equals open output.txt, right? You could say out.write I, and then you can say, oops, then you can say out.close. And that is totally fine. Yeah, so out does return, or open does return.
So the return value is the success of failure.
The return value is,
Of open.
the return value of open is a file handler for this file.
Doesn't exist.
And if it doesn't exist, then this line should, so if we're writing, then it won't crash, but if you are opening, then this will crash with an exception, which you can catch. I just haven't had I don't have the exception logic here.
And if it exists, then you have an actual file handler.
the program will crash.
It'll crash on the statement.
Yeah. Yeah. I don't remember if it, yeah, I think it crashes on this statement. I don't think it crashes on here. But I don't know the semantics of that. Okay, any questions about files? Okay. Okay. So this is what a class looks like in Python. So you use this class keyword. This is the name of the class, and then this is the class that you want to inherit from. So I think it's been a while since I've done Java, but I'm pretty sure everything in Java inherits from object. Is that true? Yeah, but they use capital O for object. In Python, you use lowercase o. I'm pretty sure this is actually optional if you want to do it from object, but I always do it just because. So this is what a constructor definition looks like in Python. So you say this def, which means you're defining a method. Then you use this super strange underscore underscore init underscore underscore. So first, these are the two arguments that you're going to pass this method. So we're creating a constructor which takes a name and an age. So if you're coming from a Java world, you have this this operator. You have this operator which allows you to access the data members. In Python, the equivalent is the self operator. And when you are defining an instance method, the self argument always has to be the first argument. Right? So in every instance method, I'm going to have self, even if I don't accept arguments. It's sort of the way that you define an instance member. And here, I'm actually assigning the name data member equal to the argument, and then you say self.name equals name. You don't have to pre-declare this variable like you do in Java outside of the constructor. You just do it within the constructor. And so this will create two data members for self, and it'll be a name and an age. Okay, I know that's a little weird. So here, just a method which returns if the person is an adult, so it checks to see if the self.age is greater than or equal to 18. If it's a child, so I was just demonstrating here that this is how you access data members with the self keyword. Then to call other methods, or instance methods with the self keyword, you just do it as you would. So basically, self is equivalent to this in Java. Any arguments have to come after the self. Okay, so this was something, so this is where I was demonstrating, I forget what it's called, it might just, it's just dot equals in Java. So to override the double equals operator, you use this weird underscore underscore EQ, and you pass it the other object to which self is being compared. You do your normal logic, and you return a Boolean to indicate whether or not these two things are equal. I see a couple of confused faces. Is there anything specific that I should go over? Of course. Okay, so let's assume that everybody understood how I declared a class this way, and now I just show how you actually use the class. So in Java, you would actually say person P equals new person, but because we don't have types, we don't say the first person, and we don't use this new keyword. It just looks like this. And then you pass the arguments. Notice that you don't pass anything for self. That's not how you do it. You just ignore that argument, and you pass the name and the age. Python doesn't directly have this notion of private or public data members, which is good or bad depending on how object-oriented you want to be. But to access the data members, you just directly say like p.name or p.age. And so basically all of the data members are public. And if you say p.age plus gets 1, that actually edits the data member. Methods are called exactly how you'd expect them to be called. So you say p is adult, p.increment age, and then display the age. Here's where I'm demonstrating how the equality operator works. So when you say p double equals p2, it's going to take p and it's going to use it as the self argument to the EQ method, and other will be p2, and it will run this equality method. Cool. Okay, so with the exception of exceptions, I think I've covered most of the Python kind of vanilla language basics. So it's a good pausing point to see if anybody has any questions about what I said, because I do feel like I went through it fast, because it's sort of hard to cover an entire programming language in an hour. Okay, so then what I have for the remaining part of this is some examples of useful packages. So package management and libraries in Python are really, really easy. They're very easy to install. You install them with the pip operator, and I have some examples right here, and they're really easy to include in the project. You use the import statement, which I'll show in a second. So now I'm just going to go over some Python packages that I think everybody should be aware of, that you will probably use a lot throughout the class. So the OS package is really useful for interacting with the operating system, with the file system, and that sort of a thing. And so the way that you declare to Python that you'd like to start using a package, you say import and then the name of the package. So we'll say import OS. Yeah.
Is there like some central database of Python packages? Like,
Yeah, so pip, so there is, I forget what it's called. It might be like, yeah, PyPy. So this is sort of where, so when you do, where did it go? So when you, on the command line, you say pip install numpy, what that actually does is that it goes to this database of packages, and it finds the one with the same name, and then it'll install it. So this is where you can search for packages. Generally how I do this is that I don't know how to do something, so I say, Python, how do you, I don't know, iterate over items backwards? And I see a Stack Overflow post. I see in the Stack Overflow post that it says, import this package. And so I put that in my code. If my code crashes, it's probably because the package wasn't there. And then I say pip install that package name. And 99 times out of 100, this works. And so that'll be sort of the development cycle for what you do. Yeah, but that's a good question. Sorry? Yeah, yes. I don't know if it's a requirement, but I think everything that you use, like NumPy or Scalar, they will all be open source, yeah. The OS package comes by default in Python, so you don't actually have to install that. But okay, so this is actually how you declare that you'd like this to use this library. I'll talk about this in a second. So common things that you might do is you say os.lister, and that will list all of the files and the directories within the current working directory. If you pass path to dir, if you pass something like this, it will list all of the files within the directory that you pass as an argument. And so if you need to loop over a whole bunch of files within a directory, you can use something like this. Some common functionality is to get the directory name of a path that you're given. So you can use this dir name and it will return the string, which is path 2, or you can use base name, which will give you just the file name without the path. So let me insert a cell below. So this help thing, which I glossed over, help is really, really useful in Python. So what you can do is that, let me just make sure that let me just make sure that that runs. Great. So let's say I have this new package, or I have an object, and I want to know what functions there are, what data members there are, what is the documentation. You can use this help keyword, so you say help, and then I'll give it the name of a package. And I think this will print a lot of text. So this is what it prints. So it prints all of the documentation about OS and all of the different classes which you can use, the documentation for all the classes. This is a huge package, so it has tons and tons of things. But it will be your friend, so if you're trying to figure out how to do something. So let's see if I say help string. So, gosh, this is annoying. Okay, it's not scrolling. I don't know why it's not scrolling. There we go. So help on a string, it'll give you all of the methods available to the string. So if we scroll down to some, right, it'll have a capitalized method, a caseful method, a count method, an encoding for changing the thing, a find method, right? So if there's any normal string operation that you want to do, you can search through here, and it will give you the documentation for it. Okay, so that's the OS package. The collections package is a nice package which has some data structures that just kind of simplify your code and prevent some errors. So the package is actually called collections, and within collections there are these two classes which I use all the time. One is called default dict, and one is called counter. And so you can use the syntax to, from a specific package, import specific classes or specific sub-packages. And so once I do this, then default dict and counter are both classes which are defined within my code. Okay? So the default dict is nice because if you, in Java, or, whoops, if you say d equals this, and then you try to print the dictionary value of 0, this is going to crash because the key does not exist. Sometimes that's really annoying because you sparse matrices and things like this. So instead what you can use is that you can use a default dict type and you say what the default value should be. So I say d is a default dict and the default type should be an int. And so when I print d of 0, previously this was going to cause an error, and now what it does is that it just returns the default value for this dictionary, and it'll be 0. And so this will prevent from crashing. So this is just sort of nice. It removes an if statement from your code, basically. But other than that, it behaves exactly like a dictionary does. So you can assign values. So you say d of 1 equals 7, and then if you query it, it will return 7, and this is key checking. Okay, the other one, the counter class, is basically used when you need to count things, which happens a lot. So you say c equals counter, and then you say c of the value of a plus gets 5. Now this would crash in a normal program because the key a does not exist because we're using the plus gets operator. So plus get sort of assumes that there's already a value to which it's being added, and so this will not crash, and then the value of a will be 5. You can also initialize the counter with a list or an iterable set of items, and it will iterate over all of them and count for you. So this is basically a nice, so it counted that there were 3 C's, and it will tell me that. So these two classes just might simplify your code and make things easier and faster to program. Okay, let's see, I think we've got 3 more packages, and then the random package is for generating random numbers. You've seen this all the time in your other programming languages. This is the particular syntax. So randint will give you a number between 0 and 5 inclusive, so it'll give you 1, 2, 3, 4, or 5. Random will give you a random number between 0 and 1, as it would in other programming languages. One thing which I use a lot is if you have a list and you want to shuffle it, you can say random.shuffle and pass it the list, and it will do an in-place shuffle of those arguments. And so A will be some random permutation of the numbers 0 through 5. The seed can be set. So if you say, I think it looks like this, and you say random.seed, it will do that. So yes, that's a good question. So the seed can be set. Now, the reason why I didn't originally include that is because I thought this point was nuanced, but maybe people will care about it. So the next package is called NumPy. It is the matrix library or numerical computing library for Python, which is used an incredible amount. So it's very good to be familiar with it. I'll get to it in a minute, but NumPy has its own random number generator, and you have to seed both of them independently. So I think you can say, and I think it's just like this, seed 1, and if you don't seed both of them and you use both random number generators, then you're not going to get consistent results. So it's important to know that you have to seed both of them. Okay, so I've shown you 2 ways to import things so far. This is a third. So you can say import a package, and then you can say as np. So np is just an alias for the package name, so that you don't have to write out numpy all the time. You can just say np. And this is a very, very standard way to import the numpy library. Okay, so like I said, numpy is mostly used for matrices and vectors. So how do you initialize these sorts of things? So if you say np.zeros and you pass it a size argument, v is now a vector of length 5, which is all zeros. Then it sort of behaves very similarly to a list where you can index it, you can set values, you can use all of these range operators. So here I'm kind of doing something weird where I'm saying the vector from indices 2 to 5, not inclusive, is equal to this list. And so it will take this whole list and stick it into that range for the vector. If you want to get the size of the vector, you use the .shape data member, which will return a tuple of all of the size of the dimensions. And so if you want to get the first dimension, you can say v.shape of 0, and this will return 5. Right, so this is just one-dimensional vector stuff. So if you want to create a vector of random numbers of length 5, you np.random.rand and 5, and this will return here a random vector of numbers between 0 and 1. If you have 2 vectors and you want to compute the dot product, which you guys will do a lot, you can say np.dot, and then v and v1, and that will compute the dot product between them. If you have 2 vectors and you want to do element-wise multiplication, these 2 statements are equivalent, so you can use the star operator or do numpy.multiply and pass those 2 things, and it will return the element-wise multiplication. NumPy is very smart, and it can figure out based on the types about what you want to do. So if you want to multiply all the values in v by 5, then you can just say times 5, or if you want to add by 3, you can just say add 3, and it will do what you want it to do. That's basically the NumPy model. Okay, questions so far about vectors? Next I'll go into matrices for NumPy.
Would that assignment where you assign a range of values
Yep.
work if instead of putting the 3 different numbers, you just put one number, like say just put equals 5?
No, so if you say the range from 2 to 5 equals 5, it will crash because it knows that the dimensions are not equal.
Okay, is there any way to like fill a certain range with
Probably, but I don't know. Yeah. So what I would do in this situation, the question was, is there a way to fill a range with like a number 5? So if you said 2 through 5 equals the number 4 and you wanted the 4 to fill in all of those slots, I would say NumPy fill an array with the value, and then I'd find the Stack Overflow post which tells me how to do it, and then I would do it, yeah. Okay, matrices work very the same way. Vectors are just one-dimensional matrices. So things are going to be very, very similar. So this just creates a matrix where all of the values are 1, and you pass it a size as a tuple. So this is actually just one argument, and if you say t equals 3, 4, t is actually a tuple, and there are 2 items in the tuple, and it's a 3 and a 4. So this is actually one argument that I'm passing here, and it looks like that. And so what this does is that it will create a 2-dimensional matrix with 3 rows and 4 columns, and it'll look, when you print it, it'll look like this. Just as before, to get the shape, this returns a tuple with 3 and 4. To get specific dimensions, you can index with the hard brackets. So now when you index the matrix, because it's 2-dimensional, you actually have to specify 2 different dimensions in order to get to a specific entry. This is very similar to MATLAB. So you can say x of the first x of the index 1 row and the index 3 column. And you set that value equal to 8, and that will insert 8 into the matrix. The colon operator is also pretty powerful. So if you use a colon, it will select the whole range. And so if you just use a colon on its own, like here, you say x of 1 comma colon. This will take the index 1 row, and it'll take all of the columns from that row. So this is the 1, and this is saying select all of the columns. And so row 1 ends up being a vector, which looks like that. I'm pretty sure these are references and not copies. Similarly, you can do the same thing for columns, and the range indexing, like we did before with the vector, also works here. It can be used to assign values. Yeah, it's a pretty powerful library. So matrix multiplication, this might be something which you all encounter. So here I'm just creating a random matrix of 4 rows and 5 columns. To do matrix multiplication between x and y, you use this matmul function, and it will return a matrix with that's a size 3 by 5, which is the matrix multiplication.
When you use the matrix multiplication, does the order you put them on means that one's on the left, one's on the right?
Exactly. Yeah. So because the which values on the left and right for matrix multiplication matters, this is equivalent to, x, y in matrix notation. Yeah. Good question. Okay. The transpose function, very useful. You can either write out dot transpose if you like to be very verbose with the function, or you can say dot t. These are the same things, and so it'll transpose a 2-dimensional matrix. Then another way to create a matrix instead of doing this random or zeros or ones is that you can pass it a list or a list of lists kind of recursively, and it will create a matrix from this list of lists. So here, if you kind of look at the indentation here, I'm basically trying to create a matrix which looks like this, and it does exactly what you would expect it to do. If I accidentally passed it something which looks like that, the program is actually going to crash because the dimensions are not exactly how they should be. I won't go over these in detail just because they're kind of boring, but there's just a whole bunch of different ways to initialize matrices that you all might find useful. So you can do zeros, ones, you can do an I, which is like the I variable in matrix notation, or you can do random doubles or random integers within a specific range of a specific size. Okay, I think that sklearn, yep. Okay. So the final package which I want to talk about is something which pretty much everything that you can think of, yeah, it'll do it. So it'll compute norms.
Or the rank or whatever.
Yep, it'll compute rank. Yeah, so there's a linalg package. I think it might be in SciPy, but yes, it does. So if you search for computing the norm of a matrix NumPy, it'll come up like Stack Overflow will be able to help. Yeah, I just tried to include some very basic and common things that you'll probably have to do here. Joining data sets? Sorry, what do you mean by joining? Like you want to append one to the other? Yeah, so there might be, I don't know, there could be a function which exists in NumPy that I'm not aware of, which will do exactly what you're talking about. But the other thing that you could do is that if you have two matrices and you want to kind of concatenate them together, you could create a third, which is the correct output size, and then you could use the range notation to fill the matrix that you want to assign to those two values. Does that make sense? So if you have 10 rows of something and 20 rows of something else, you could create a matrix with 30 rows, and then use that range assignment notation to say the first 10 rows of the output equals the first one. The second 20 rows of the output equals the second one, right? So you can copy all of that data over into one larger matrix. Yeah, so if you have millions of operations, then you might have to you might have to come up with a tailored solution to your particular problem. So you might know beforehand what the matrix size is going to be because you've written that as the first line in your data file. You read that and create a matrix of that size, and then you iterate over your data and assigning those values into the matrix. So there, there's not one good solution for everything. You just kind of have to pick. Yeah, there's a hand somewhere in the hand.
I just want to say that I think there's like a method called concatenate.
Yeah, okay. So there's a concatenate method which will do Okay, I think I can cover this in just a couple of minutes, so then we'll end the class at that time. So sklearn is a very popular machine learning library in sort of the data science community. And here, what I just have here is a simple way to train some sort of classifier or linear function like you saw on Monday. And so you say from sklearn.linear model, import this. You'll understand what all of this means later in the class, but you might use this kind of template for your assignment. So I've created X as a matrix, which is this binary thing. I copied it from the lecture last time, so you can see those in the slides. So this is a matrix, and then Y is now a vector with all of the binary labels for each row in this matrix. So if you recall, each row is an instance, and each column is a feature of that instance. And so Y, there is a binary label for each row with an X. You kind of create the classifier this way. You'll learn about what the arguments are later. And then when you actually want to train the model, which means to find the function that Professor Roth was talking about, which kind of separates the data, you use this fit method. And so fit accepts the feature matrix X and then all of the Y's for all of those rows. And it will run and it will kind of try to find a function which fits this data and separates the zeros and the ones based on the features. And then in order to predict on new data, which I think we covered a little bit, I created this sample test matrix with these random values that I came up with. And then you say the classifier dot predict, and you pass a new feature matrix. And what this will return is this will return a vector of size 3 with 0 or 1 based on the output from the function that the classifier learned. And let's say I actually know the ground truth for this value. This is just sort of a way of calculating the accuracy. So this is a vector. This is also a vector. If you use double equals, it will do an element-wise comparison, and it will return a vector with Boolean values. And then if you use the sum function, it will sum them up. It will treat them as 0 or 1, and it will count the number which are actually correct. And then you can divide this by the total, which is just the shape, and then I printed the accuracy. And so it's okay if you didn't understand a lot of this right now. Later on, you'll understand what all of these components mean, and then you can refer to this for how you should set up the pipeline. Yeah?
What's that scary looking metric?
This is a warning, and I just ignore warnings because they're not errors. I have no idea. It has something to do with the tolerance of the classifier and this whole nonsense. I don't really, you should look at it and decide whether or not you care about it. Yeah. Okay, if you have any specific questions about troubleshooting the Python installation, come to the recitations or office hours. Other than that, thanks. Yeah.
Have this available in Piazza? Are you gonna
Yeah, so it already is on Piazza. I posted it last night. I made very minor modifications.
Piazza is like a first year here.
Okay. Yeah.
How we can use it, Piazza.
Okay. Yeah. Okay.
A lot of different websites. Just
I understand. So there should be a link to Piazza on the website. So Piazza is just like a forum where people can post questions and then the TAs or other students can respond, and it's sort of a Q&A sort of a thing. So I made a post last night about this, and I attached these files. So if,
So this is also
yes,
specific IE.
exactly. Yes, this is on there. So you should be able to join Piazza without, I don't even think you need to be in the class to join Piazza.
Also, when is the recitations? Because I can't really
So
figure out what.
the recitations are on the,
Piazza also.
they're on the website, so they're right here. So there's one today at 4 and then one tomorrow at 5. They're optional recitations, so you don't need to go to them, but those are the 2 times that we have available. Yeah, so they're on the website if you can find that. Yeah. I'd like to, yes. Yeah, hi. Yeah. Okay. Yeah. Um, other than emailing him, no. So, no, you can email. Yeah, he likes email. He responds very well to email. He is traveling right now, but I think he will let you sit in on the class if you can't audit it. So I guess auditing would mean that we would grade the assignments. So I don't know how that's going to work, but I don't think he would have a problem with you sitting in. And all of the homeworks and solutions are going to be public, so you can still do them, but we might not grade them. Yeah, he's going to publish everything on the public website. So yeah. Okay. Okay. All right. Yeah. Thank you. Hi. Yeah.
So for the class we're having in person, we did like p.age, right?
Yep.
And you said, so if I did like if p.age plus 1 is greater than 19, would that modify p.age?
No. It's just as so do you have a programming background in another language?
Yeah.
Like Java? Java. Okay. So yeah. So if you said, let's say int, if x is an int, and if you say if x plus 1 is equal to 3, that doesn't actually.
I thought you said it was
So if you say p.age plus gets 4, the plus gets will
okay,
edit the
but if
value.
it's an if statement, it's fine.
Yep. Yeah. Hi. Okay. Yeah. 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 To the lectures? So, I think it would be pretty easy because all the lectures have been recorded. So, if you have access to Canvas, they're on Canvas, and eventually we're going to migrate them to YouTube as well. So you can actually watch the original lectures. So far, there's really only been introductory material covered, so I think it should be pretty easy to catch up. And even we didn't have class the first day, so you really haven't missed that much. Yeah. Yeah. So the homework 0, we still like you to do it, is sort of examining, or it's telling you this is the mathematical background which we think that you should have to be able to take the class. And we're going to grade it as a pass-fail just to see if you put effort into it, and it's sort of helping you decide whether or not you're going to be able, how successful you'll be in the class. But when you finish it, if you can't submit it on Canvas, just email it to me. No. Yep. Mm-hmm. Mm-hmm. Yep. Hi. Can I answer? Yeah, it might be. Does anybody have? You have a longer question, I think. Does anybody have a shorter? Yeah. So you install Python 3. So if you type Python 3 in here instead of Python without a space, and hit enter. So now that uses Python 3. Yep. Yeah. No. So that's not. It's not trivial. I understand that. Yeah. The Jupyter Notebook. So I think what the guy set up there is that if you install, so if you go to the Jupyter website and they have the pip instructions on how to install, you should say pip3 install Jupyter Notebook. And then when it sounded like when you use Jupyter Notebook on the command line, it will use 3 by default. I think that should be true. Yeah. I think it's just sort of like the implementation. So I think in Python, when you actually say, let's say I had an isAdult method, it'll say p.isAdult. And then what I think behind the scenes happens is that there's an isAdult function. It takes p and it substitutes it in as the first argument to this method. And then the method gets run. So the p actually becomes the self. Oh. Does that make sense? Yeah. Yeah, so that's what's happening. So the self is like the this operator. Yeah, it's a little weird, but yeah. 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 So I'm not actually sure what an SGD classifier is. So I don't actually know what's going on behind the scenes, but in the class you'll learn about all kinds of different classifiers and models which you can use, and you might want to choose a more expressive model. So if you were in the class last time, I think the professor was talking about the hypothesis spaces, and so maybe the one which is using here, it's not a very big hypothesis space, so it's finding a small, and it actually can't separate the data effectively. Yeah. Yeah.
I'm not understanding the gradient and all this kind of, towards the end, this kind of mathematical.
Okay. In the homework 0?
Not
Or
homework zero, there is a
oh, was there? Okay. Okay. I mean, I can help you. You can also the office hours are listed on the website, so you could go to any of the TA's office hours and discuss them, and they should be able to help you. Yeah.
lastly, I'm planning to have
Okay. So the Canvas. So are you officially auditing, or are you just sitting in on the class? Okay. So then I don't think that you're going to be able to access the Canvas. But, the only thing that you'll miss out on are the quizzes, which might be okay because they're just very short quizzes. But all of the assignments will be posted on the website for anybody to access. The class website. So if you don't have the class website, you can write that down if you want.
Oh, okay.
So this has all of the information, yeah.
So it'll be in homeworks?
So on the syllabus, we'll put, like when homework 1 comes out, we'll put a link to it here. And then
Okay.
this is publicly accessible, so anybody can
okay.
access it. So Canvas is really only for these quizzes.
You just put the question.
Yeah.
Thanks.
Okay, sure. Okay, hi. So I think I should be able to answer your question. I wasn't, okay, so go ahead and ask it again, because I wasn't paying attention when Dan, or the professor was going over this, so hopefully I understand what's happening. But
Okay. Or do you think we can talk here because it seems like there is a course.
yeah, so let me pack up my stuff. I have to be somewhere at 1:30, which is in
Oh, that's
just a few minutes. Yeah.
So, do you think any other time works?
So you go to the office hours, and I will. There people should be at the office hours. Like we're hosting office hours now, so. I mean, not at this exact moment. But I mean, we've started hosting office hours. So let me just.
Because my case is a little bit special, so I cannot get access to the Piazza or Canvas or any other stuff.
So everything is on the website. So if you go under staff, this will list the office hour times. So the TBD, because you're not on Piazza. I understand. Okay, I understand. So we're still trying to find spaces for people to host their office hours. So if it says TBD, it is outside of the professor's office. So there's a common area there. And so if it says TBD, this is where they should be. Some of them are in this room, right? It sounded like this is where you went.
Yeah.
And so I guess this was yesterday. Did you go from 3 to 4? Oh, because this person had to cancel the Tuesday office hours, and it hasn't been updated. So he changed it to Thursday. So, okay, so try one more time in office hours based on this. You should be able to join Piazza without being in the class. You can? Have you tried?
Yeah, actually, my identity is like not a student.
Okay. Okay.
Yeah, so I cannot I haven't grabbed my computer.
Okay. Okay. So at least try the office hours one more time, and if that doesn't work, then you can email me.
Yeah, actually, I should this thing with you because actually I'm a research assistant hired
Okay.
by Professor Ryan.
Okay.
And my professor sent an email to Dan actually.
Okay.
And he said maybe I should reply to
Okay. Okay. So you can come to my office hours, which are Monday from 10 to 12, or you can also email me, and I'll respond to the email. So let's step out. Hold on, I just need to give you